Hello everyone, welcome to my YouTube channel. This is Unit 1 Electrostatics, and the topic we are going to discuss is electric field due to single point charge. Let us step into the article without wasting a moment, and let us consider a coordinate system comprised of three mutually perpendicular axes, that is x-axis, y-axis and z-axis. These three perpendicular axes are making angle of 90 degrees with each other, and we will consider a source charge S to be placed at origin, that is plus Q, and we will mark the origin as O. Now we know electric field lines always act in the outward direction, therefore we will make one single electric field line because making more lines will make the diagram messier one. And let us consider a point P which is at distance R from the source charge which is placed at the origin, and now unit positive test charge plus Q naught is supposed to be placed at point P, but it has to cover all the distance. We will consider a point A on the same line which is lying at distance x from the origin. Now plus Q naught charge will cover the distance A to B, B to P, and let us say it is covering a small distance AB which is equal to dx. Now plus Q naught is a unit positive test charge. Therefore, we will take its magnitude as 1, that is test charge is equal to plus 1, and now it is moving from infinity. Therefore, we know that V is equal to dW upon Q naught according to the definition of the potential, which is further equal to E dot dx. We will solve this equation. Therefore, we are having V is equals to dW upon 1 because the magnitude of Q naught is taken as 1, which is further equal to E dot dx, or we can say V is equals to dW is equals to E dot dx, and we will solve this equation. Now V is equal to integral of dW. We will find the total work done, which will come out to be W is equal to integral E dot dx. Now the electric field lines are acting in the outward direction and the distance dx is in the inward direction. Therefore, E is acting in the outward direction, dx is in the inward direction, making the angle 180 degree anti-parallel lines. Therefore, we can say the dot product will be cos 180. So W is equal to integral E dx. Removing the dot sign, we will write cos theta, that is cos 180 degree. And now plus Q naught charge is coming from infinity, and we have to place it finally at point P, which is at distance R from the origin. Therefore, we will take the limit from infinite to R. Therefore, we have V is equal to W, which is equal to integral infinite to R E dx, and we know cos of 180 is minus 1. Now therefore, we have V is equal to W is equal to minus integral infinite to R E dx. We are already aware about the value of E. Therefore, we can say V is equal to W is equal to minus integral infinite to R 1 upon 4 pi epsilon naught Q upon x square, because initially we are placing the charge at point A, and dx. So we have V is equal to W is equal to minus Q upon 4 pi epsilon naught integral infinite to R x raised to power minus 2 dx, and we will take the constants out of the integral because these are not required inside the integral. Therefore, we can say V is equal to minus Q upon 4 pi epsilon naught, and we know integral x raised to power minus 2 is x raised to power minus 2 plus 1 upon minus 2 plus 1, and we will write the limits infinite to R. So we have V is equal to minus Q upon 4 pi epsilon naught x raised to power minus 1 upon minus 1 infinite to R, taking the limits once again, and now we can say V is equal to plus Q upon 4 pi epsilon naught because we can cancel minus and minus, and plus Q upon 4 pi epsilon naught 1 upon x, taking the limit infinite to R, Therefore, we will substitute the limits now. Q upon 4 pi epsilon naught 1 upon, we will replace x by the upper limit, that is r. So we will write 1 upon r minus 1 upon, we will replace the x again with the lower limit, that is infinite. Therefore 1 upon infinite. So we have substituted the limits now, and we will further write that we know 1 upon infinite is 0. Therefore we have v is equal to q upon 4 pi epsilon naught 1 upon r minus 0. And the final expression which we are having is v is equal to 1 upon 4 pi epsilon naught q upon r. So this is the final expression for the potential. And now we will consider the case that if source charge is placed anywhere instead of being placed at origin. So if charge is placed anywhere other than the origin, here in this case we have v is equal to 1 upon 4 pi epsilon naught q upon distance between source charge and the point charge. We will mark it as sp, and sp is the distance between source charge and point of observation. Right, so this is the expression. And also we have one more thing, that is if we want to find the potential due to group of charges, in that case, that is potential for the group of charges, the expression for the potential will come out to be v is equal to 1 upon 4 pi epsilon naught summation qi upon ri, where I is equal to 1 to n, and this is the final expression for the potential for the group of charges placed at the different points. I hope you have understood the article. If yes, then do not forget to press like, subscribe and share button, and do press the bell icon in order to get the latest notifications on my videos.